Continuing on with the subject of nomenclature, in this video we want to go from a name to a formula, which is the opposite of what we did in the other video. Right, so the first step here is essentially to name what you see. And in this case, name the pieces that you see. So I see a copper, and I'm going to write the formula for copper, and I see a phosphate group. A phosphate group. Right. Now the key is to put these pieces together so that they are charge neutral, and that's the key. So to do that, we need to figure out what the charge is. What is the charge or the oxidation number of this copper species? Well, the name tells you. It's 2+. That's what the 2 means. What is the charge on a phosphate group? If you don't have that memorized, you need to recall that a phosphate group derives from the acid H3PO4, which is phosphoric acid. And the anion to that, I just lost 3 protons. So you can say, I just lost 3 protons. And so the resulting group from a phosphoric acid is a phosphate, and it necessarily carries a -3 charge. And now it's just a matter of playing the math game here, which in this case is cross multiply. I see a small even number and a small odd number, and so to get the charges to match up, I'm going to multiply this one by 3, so that 3 times 2, and I'll multiply my entire phosphate group, because it's the entire group that carries the -3 charge. So I'm going to multiply that by 2. And you can see from the math there, it's necessarily going to work out, because necessarily 3 times 2 is going to equal to 2 times 3. So this cross multiply is a very nice trick in order to get an odd number and an even number, to get those lined up so that the charge on both sides of this formula, as it were, the positive part and the negative part, are equal. And so with that, let's clean it up and get rid of all of the red marks. So the formula for copper 2 phosphate is Cu3PO4 2. Right, and that is a type 2 compound. So let's do one more right quick. And this is, you recognize this as a type 3 if for no other reason. You see these prefixes, you see the di and the tetra. So first, let's just take the pieces that we recognize. I recognize a nitrogen, and I recognize an oxide. And now it's just a matter, of course, of figuring out what the subscripts are. And the subscripts are already declared. I have 2 nitrogens, and I have 4 tetraoxide. And so there is the formula for dinitrogen tetroxide. And with that, you should be able to go from a name to a formula. And the first video teaches you how to go from a formula to a name.